So 8.4, we're going to learn about the binomial theorem. So binomial is something that has two terms. So this would be a binomial. We've seen binomials before. We're going to have a binomial raised to some exponent. So we know if we have a binomial raised to the second power, we have to FOIL. If we raise it to any power more than that, you still have to FOIL, but it's like FOILing extreme, because you just have to FOIL with the more terms you have. But we're going to learn a shortcut on how to do that. But before we get there, we have this little formula. So our first couple examples are about this. It is NCR, so you say it as like N choose R. So just like N comes before R in the alphabet, N comes before R here. So N is the number that's on top. So you can think like numerator. So you have N factorial over N minus R factorial times R factorial. It can be written like this, or we'll see it like this too. These mean the same thing. So looking at example 1a. What's our N? N is 8, and what's R? 2. So it would be 8 factorial over 8 minus 2 factorial times 2 factorial. So this is 8 factorial over 6 factorial times 2 factorial. And then we can write this out. So 8 factorial is 8 times 7 times 6 factorial. I could keep going, but I see that I have a 6 factorial on the bottom, so I'm going to stop there because I know that those will cancel. And then 2 factorial is 2 times 1. So do I have anything that cancels? 6 factorials cancel. And then anything else? 2 goes into 8 4 times. So on top, it's just 4 times 7, which is 28. All right, B. So remember, N is on the top, R is on the bottom. So 10 factorial over 10 minus 3 factorial times 3 factorial. So this is 10 factorial over 7 factorial times 3 factorial. So on top, I have 10 times 9 times 8 times 7. I'm going to stop there because I know I have a 7 factorial on the bottom that it'll cancel out with. And then I also have 3 times 2 times 1. So I can cancel out the 7 factorials. Anything else I could cancel? 9 and 3. So 3 goes into 9 3 times. And 2 goes into 10 5 times. So on top, I have 5 times 3 times 8. So what would that be? 120. All right, so let's look at C. So I have, what's N?
7.
N is 7, so R is 0, so it'll be 7 factorial over 7 minus 0 factorial times 0 factorial.
So that just cancels, right?
So it'll be 7 factorial over 7 factorial times 0 factorial. What is 0 factorial? 1. So this is 1. So I have 7 factorial over 7 factorial, which is 1. And then the last one, we have 8 factorial over 8 minus 8 factorial, bless you, times 8 factorial. So this would be 8 factorial over 0 factorial times 8 factorial. And what's 0 factorial? 1. So this is just 8 factorial over 8 factorial, which is 1. Example 2 is the same stuff, so I'm going to skip it. just because we have a lot in this section. So if we have time, I'll come back and do some more. All right, so next we have Pascal's triangle. So you guys learned this in Algebra 2. Hopefully you remember. But Pascal's triangle is a way to find our coefficients in a binomial. So it helps us with the binomial coefficients. Down here, it's the same Pascal's triangle, but it just has our variables with it. So the first number on top, the 1, is not a row. So this would be like the 0 row. And then the one with 2 ones is your first row. So this is the first row, second row, third row, fourth row, and so on. The way we can find what our next row is just by adding the 2 numbers above. So you see here, we have 4 plus 6, which is 10. So if we wanted to find the 8th row, always start with 1. And then what's 1 plus 7? 8. 7 plus 21? 28. 21 plus 35? 56. Yes, always start with 1. So notice here how each row starts with 1. 35 plus 35? 70. 35 plus 21? 56. 21 plus 7. And 7 plus 1. And then you end with 1 also.
So if you were to write that,
So in our triangle, it's always going to start, every row starts with a 1. So if you were asked to write like the first 4 rows of Pascal's triangle, and we didn't have it with us, we don't know what it is. You always start with a little triangle of 1s, and then just start with 1 and add the 2 above. So this would be 2, end with 1. So this would be 3, but we start with 1. This is 3, end with 1. This is now 4. We start with 1. This is 6, 4, and end with 1. Yes. And then whatever the number, like the second number is, that tells you what row it is. So this would be the second row, third row, fourth row. All right, example 3. So we're expanding the binomial. So here, this is like saying x plus 1 times x plus 1 times x plus 1, which we could FOIL the first 2 and then FOIL that with the last one also. It would just take a while, especially when we get into like an exponent of 5. It would take a long time. So our Pascal's triangle is a shortcut. So with our exponent here, that's the row that we want to look at in our Pascal's triangle. So here we're going to look at the third row. So we're going to take the coefficients of the third row, which is 1, 3, 3, 1. So we're going to start with that. 1, 3, 3, 1. Our second row comes from the first term in our binomial, so that'll be x, which I'll just rewrite here. And then the third row comes from the second term in your binomial, so 1s. Now whatever our exponent is, that's what we start with as the exponent for our x's, so it'd be x to the third power. And then from there we decrease by 1, so 3, 2, 1, 0.
why did you write it?
The second number here, 1, our third row that we have, we do it in reverse. So our exponents start with, or I guess end with 3 and then go down from there. So 2, 1, 0. So if you wanted to start with 0 and then go up. But one way to always check that you did this right is that our exponent is 3. These numbers will always add up to 3. So 3 plus 0 is 3, 2 plus 1, 1 plus 2, 0 plus 3. It'll always add up to 3 to make sure each column is right. Whatever your degree is, it adds up to. So now we multiply the columns together. So we start with our first column. So we have 1 times x to the third power times 1 to the power of 0. What's 1 to the power of 0? Just 1. And then what's 1 times x cubed times 1? Just x cubed. So you multiply the column together. So in the next one, I have 3 times x squared times 1, which is 3x squared. And it's positive, so it'll be a plus. Then in the next column, I have 3 times x times 1 squared, which is 3x. And then in the last column, what is x to the power of 0? 1. So I can cross that out and put a 1. So it's 1 times 1 times 1 cubed? 1. So this would be our answer. All right, so example 4. So this is kind of the same, but it's x minus 1 to the third power. So my degree is 3. So I'm looking at the third row of Pascal's triangle. So what's my third row in Pascal's triangle? What are the coefficients? 1, 3, 3, 1. Then my first term in my binomial is x. So I have x. What's the degree on x going to be? X cubed. Then we go down from there. X squared, x to the first power, x to the power of 0. Then my second term in my binomial here is what? Bless you. Negative 1. So negative 1. What's the first degree going to be here? To the power of 0. Negative 1 to the first power. Negative 1 to the second power. Negative 1 to the third power. We could double check that we put the exponents right because it's always going to add up to 3 because our degree that we started with was 3. So then we multiply our columns together. What is negative 1 to the power of 0? 1. So this is just 1. So it's 1 times x cubed times 1. X cubed. What is negative 1 to the first power? So it's negative 1 times x squared times 3. Negative 3x squared. What is negative 1 to the second power? Positive 1. So it's 3 times x times 1. 3x. Positive 3x. So it'll be a plus. And then what's x to the power of 0? Just 1. So I can cross that out and put a 1. And then what's negative 1 cubed? Negative 1. So it's 1 times negative 1. Negative 1. So this would be our answer. Yes. Also, when it's a minus, so if your binomial has a minus in the middle, your signs are always going to alternate. So it'll start with a positive number, then go minus, plus, minus. So your signs always alternate when it's a minus in the middle.
It's always going to start positive?
If the first number starts positive, so if this is positive, it'll start positive.
Is that answer called binomial?
All right, so example 5a. We're doing the same thing, but here we have 2x minus 3 to the fourth power. So what row are we looking at for Pascal's triangle? The fourth row. So what's our fourth row in Pascal's triangle? 1, 4, 6, 4, 1. Now what's our first term in our binomial? 2x. So I'm going to start with 2x. And what's my degree going to be on that 2x? Fourth power, because my degree overall is 4. So fourth power, what's the next one going to have? Cubed. Then 2x squared. So it just decreases from there, 2x to the first power, and then 2x to the power of 0. What's my second term? Negative 3. So here I'll have negative 3. What does the first one start with? What degree? The power of 0. Negative 3. What comes next? First power. Negative 3 squared. Negative 3 cubed. Negative 3 to the fourth power. And you can always double check to make sure you put the exponents right because they're all going to add up to what? 4. Because our degree is 4. All right, so let's multiply our columns now. So you have to be careful here because this is 2x to the fourth power. So we have to distribute the 4, the exponent of 4, to the 2 and the x. I would say last year that was like the most common mistake that anybody made. They did not distribute. So I'm telling you now, don't forget, you have to distribute. So what is 2 to the fourth power? 16. So it'd be 16x to the fourth power. What is negative 3 to the power of 0? 1. So I can cross it out and put a 1. So this is 1 times 16x to the fourth power times 1, which is just 16x to the fourth power. Our next column, we have 4 times 2x cubed. So that cubed gets distributed to the 2 and the x. So what's 2 cubed? 8. So this is 8x cubed. And then negative 3 to the first power is just negative 3. So it's 4 times 8x cubed times negative 3. What is it? Negative 96 x cubed. So then for the next one. Now that squared gets distributed to both things on the inside. So it's 6 times, this becomes what? What's 2 squared? 4x squared. And then what's negative 3 squared? 9. So it's 6 times 4 times 9 times x squared, which is 260? 216 x squared. So in the next one, it's 2x to the power of 1, which is just 2x. And then what's negative 3 cubed? Negative 27. So it's 4 times 2 times negative 27, which is negative 216 again. X, because we just have one x there. And then the last one. What is 2x to the power of 0? 1, so that'll cancel. And then what is negative 3 to the fourth power? Positive 81. So this is 1 times 81, which is 81. So again, notice here that we started with a minus in the middle, so our signs alternate. It goes plus, minus, plus, minus, plus. This is our answer. So it is x minus 2i to the fifth power. So we're looking at what row in Pascal's triangle? The fifth row. So what are our coefficients in the fifth row? Perfect. 1, 5, 10, 10, 5, 1. And then we start with x to what power? X to the fifth power, then x to the fourth power, x cubed, x squared, x to the first, x to the 0 power. And then what is our second term? negative 2y. And what's the degree on that? 0. Then we go up from there. So negative 2y to the first power, negative 2y to the second power, negative 2y to the third power, negative 2y to the fourth power, negative 2y to the fifth power. You can always double check because each column, the exponent's going to add up to what? To 5. All right, so let's multiply our columns together. So what is negative 2y to the power of 0? 1. So that'll cancel. So what's 1 times x to the fifth power? Just x to the fifth power. Then in the second column, I have 5 times x to the fourth power times negative 2y. What would that be? Awesome. Negative 10 x to the fourth times y.
Does it matter where your x is and where your y is?
Keep it consistent. So if you put the x's first and the y second, do that for all of them. So don't switch it in the second or third term. All right, in our next column, we have 10 times x cubed times negative y squared. So negative 2y squared. What is negative 2y squared?
4y squared.
4y squared. Bless you. So our coefficients that we're multiplying here are just 10 times 4, which would be 40. And then our exponents are x to the third power y squared. So then the next one, here I have negative 2y cubed. So it's negative 2 cubed. Negative 8, so this is negative 8y to the third power. So the coefficients that I'm multiplying here are just 10 and negative 8, so what would that give me? Negative 80, and then my variables are x squared, y cubed. All right, and the next one, I have negative 2y to the fourth power, so it's negative 2 to the fourth power.
16.
Positive 16y to the fourth power. So I'm just multiplying 5 times 16 here, which is positive 80. And then x, y to the fourth power. And then the last one, what is negative 2 to the fifth power?
32.
Negative 32y to the fifth. And what's x to the power of 0? 1, so that goes away. So this is just negative 32y to the fifth power. So this is our answer here.